All right. Hi, Will.
Hi, Renee.
Okay, so tell us about your current status. Do you consider yourself to be a data scientist, or do you use another title? And what kind of work do you do right now?
So I am a data scientist. I work for a small company in the sort of content marketing space, and I do a whole bunch of different things. My current position is sort of like very product oriented, so I kind of have this sweet ability to be like a researcher at a small company. So I get all the nice benefits of working at a small place with a great team and really cool people. And at the same time, I get to do a lot of really experimental, fun things. So this is the current position. And when I was at KISSmetrics, a lot of my work was mainly sort of driving new product features and figuring out how we could use data science to make a better product. And so that's what I've been doing now and before as well.
Okay, great. And what are the main tools do you use? R, Python?
I use everything. So I use R, Python. I was using a lot of Scala for stuff. Lua for any sort of deep neural network stuff I've been doing. I am pretty, whenever people get really intense in these language debates, I always think it's kind of silly because I think I use at least 3 languages in a given week. So R is probably my basic, let's just crunch some numbers or look at some data. Like if I'm going to look at some data, I pull up R. But in a given week, depending on which tools or libraries are best for the job, I use multiple things all the time. So yeah, so R a lot. More recently, I've been doing a lot of stuff in Scala, and then this week, a lot of stuff in Lua. So it's been a huge range of different things.
Okay, and just so we can get an idea of the kind of work you do, can you give us an example of a project that you've done that you're proud of?
Well, currently I've been just doing a lot of experimental stuff with recurrent neural nets and seeing what we can do with sort of text models. We're working on some sort of secret things now, so I can't talk too much about my current work. In the past, I've done a lot of stuff in sort of, with KISSmetrics, I helped build out their A/B testing tool that was actually built into the product. So a combination of actually writing the A/B test logic and also some of the low-level code to handle numeric stuff. When I used to work for the federal government, I did all kinds of really interesting stuff with re-identifying supposedly anonymous information, which is really fun. So a pretty eclectic mix of things depending on the task. A lot of things I do sort of start with, wouldn't it be cool if we could do this, and then trying to figure out how that happens. So sometimes it's all probability, sometimes it's all neural networks, sometimes it's a combination of things.
That sounds really fun. Okay, so I just wanted to get a baseline of what you do now, but now we're going to go back in time. So okay. I want to know, what were you like as a kid? Did you like math a lot? Was there anything that indicated that you would later be a data scientist?
I was thinking that day, if I told like my teenage self, like, you sit at home and run fake brains on your computer, I would be like, I don't think that's a realistic future for me. Like, I was not super math. I was never bad at math. I didn't have like a aversion to it, but I never saw myself as super mathy. I was, I liked computers when I was younger, but I was never, I wouldn't have considered myself like a techie person. My high school years were probably a little bit more wild and, staying out late and doing things. So I was, I mostly was into writing when I was in high school. So I was into the lit club and all my friends were poets. So I had sort of this interesting, I sort of had a lot of fun with these sort of strange people doing fun things. And I think if you told me I would have had a career in software at all, I would have been completely shocked. Although my second grade teacher said, Will is going to work with computers when he grows up. And I always think that was basically insightful. Yeah. So,
was there anyone in your life, like a parent or a role model or anybody that worked in computers so that you felt comfortable with it?
My grandfathers who passed when I was relatively young, he got me started. So we had a Tandy 1000. So I always had computers around. Nice. Like I wasn't like an early programmer, but I always had that, sort of like computers were fun and had it. So I was early into, I was an early like chat user and everything like that back in the day, like in the mid 90s. So I was sort of active, but I was never really technical, I would say. But I played a lot of video games, and I did have a computer since I was very young. And I think, my grandfather probably got me started in that.
Okay, well, you mentioned you were in Lit Club, and that's what I found out interesting about your bio, that you actually started as an English major. So kind of take us through your formal higher education. Tell us all about that.
Well, in high school, I was, middle school I was a terrible student, and in high school I was an okay student. And at the end of high school, I was thinking physics interested me, and English interested me. And then when I got to college, I really fell in love with English lit. So, and ironically, even more, I was mostly in like postmodern literary theory and all this fancy French critical theory. So a completely, antithetical to a lot of like software tech people's worldview. So it was a really interesting time. And, I was working in libraries at the time, and it got me interested in libraries. I actually liked the sort of the community parts of libraries initially, not so much the technology parts. And so I loved books and I loved reading, and I wanted to keep pursuing that. So I should have known there was like warning signs I would develop into a more technical person. 'Cause I remember I was reading about Prolog, which is this logic programming language, and I spent one weekend building a miniature like library catalog in these hacked together Prolog algorithms. One of my computer science roommates was like, "What the hell are you doing?" Like, writing Prolog on the weekend for fun, and it was awful code, but it was something, I was sort of just curious how it worked. So that was my undergrad, and I moved to Boston to get my library science degree, and that's where I started working at MIT. And so that's
let me stop you before you go too far. What is library science?
So, library science, it's one of those things where it's sort of an interesting field. So like there's a degree for library science, and it's a lot of how you manage libraries. It's a lot of it's a very pragmatic degree, and it's necessary to be a librarian. So nearly everyone who is a librarian, like a proper librarian, has a master's of library and information science. And it covers, everything from like how do you run the finances for a library to how do you do reference, basic, and there's a lot of neat stuff in that area, because like one of the things you learn when you're studying like reference librarianship is when someone asks you, I need to find this, you don't answer their question, you're trying to figure out what they're actually trying to get. So if someone comes up, which actually comes a lot in data science, right? When people say we need to know this, it's not uncommon to say, well, what's your real problem? Like, what are you trying to solve? Like, you say you want to know the conversion rate here, but you don't really want to know the conversion rate. You want to increase sales. And maybe the way to do that is another route than what you saw. So, so it's a pretty eclectic area of, it's not, some people that are, many librarians are sort of frustrated with the library degree because there's definitely a lot of fluff in it too. But the big thing it does is sort of get you thinking like a professional librarian, so you learn to sort of communicate professionally and whatnot. So it was getting a little bit more technical when I was there, trying to add computer science classes and stuff. But and at that point, I wasn't even.
Did you think that you wanted to be a librarian at first? Was that your goal at that point?
That I'd be a librarian. I was totally pumped about it, and actually the funny thing is, and my wife still laughs about this. My vision when I started is I wanted to be like in a small town, and I wanted to be a director of a public library early in my career, and I just wanted to like read books and be in this. I had these sort of like small town fantasies, and I remember my roommate in college said to me, he said, "Well, you're gonna get really like bored with that view really quickly, I think." It's like, I know you think it's going to be fun, but I know you well enough to know that won't satisfy you. And that was true. So I did. But I ended up, my vision when I moved to Boston was I'm going to get a part-time job working at a public library, and then I'll become a librarian and become a public librarian. But I ended up getting a full-time job at MIT in the libraries there, which I didn't expect at all. And that was very sort of exciting to me. So that definitely got me started thinking about technology, obviously, because being there was it's really exciting.
So how do you think that the English background and the library science background, does that inform you now in working with data science? Do you still fall back on some of what you learned then?
Yeah, I mean, it's funny because I still think of myself, I think, as a humanist, even though like I write this probability blog, and a lot of people that don't know me well think of me as a technical. In fact, one thing I found is there's a certain threshold I crossed for an interview, and I would stress so hard my technical skills, because in my head I was like this humanities person, and people interviewing me would be like, "Man, I don't know if you can do like non-technical things, though. You seem so obsessed with these technical topics." Like, oh, that's because I'm trying to sell you on what I think is my weakness. So it does help a lot. There's sort of a hostility in certain technical fields towards qualitative things, but there's a lot of qualitative parts of reality that can only be modeled and understood qualitatively. And so it's important, I think, to have that perspective. And then, of course, the big thing is always the idea of narrative, right? Like how we tell stories is a huge part of all that, and communicating and even writing. I find myself writing now more than I ever have, and it's hilarious, and it makes perfect sense to me. Like, right, so I've built this sort of technical skill set, and I can still write. So being able to communicate well and all that. So every day, I don't view it as like a transition. Like I was a humanities person, and now I am a technical person. In my head, it's just it's an obvious continuum of thinking. There's no division between like this is the humanities will and this is the science will, and they're separate entities. It's just this long. I always joke that like Foucault and probability both equally inform my worldview, right? Like Foucault teaches us about the nature of power structures in society, and probability helps us understand the information that's in front of us and how we can reason about the world. And if you have just one or the other, you tend to be lacking some part of the big picture perspective. So yeah, anyway, that's my...
So you cover the whole spectrum then. Okay, so then what did you do next after library science degree?
After my library science degree, I left MIT and started working at BBN Technologies, which they were the early ARPANET people. That was a really exciting job. Actually, going out of libraries, I had this sort of decision where I either could go to BBN or go to actually the small town public library and be sort of upper management there. And I was like, I don't know. And I was like, I just got to go do the harder, more interesting things. So I went to BBN. And that's where I got exposed.
For people that don't know what ARPANET is, can you describe that first?
Yeah, that's the precursor to the internet. That is what the basic foundations for the internet were. So BBN Technology. So when DARPA, the Defense Advanced Research Projects, which was then only ARPA, they decided to build it. They subcontracted it out to MIT, Stanford, and BBN Technology. So BBN Technology is one of the original people who designed and laid out the network. So there was a lot of old timers there that knew stuff, and their current research at the time was heavily in speech and natural language processing, and they had some of the best people there. So that's where I got exposed to machine learning, and I remember thinking, oh, like these people are doing what librarians try to do, but much better. They're really approaching it. Problem, you know, I was seeing like people do text classification with support vector machines, and this is 2006, 2008. So at that time it was still pretty advanced, and I'm like, oh wow, like here's in libraries we have people using sort of arcane systems to catalog things, and here we have scientific algorithmic approaches to classifying text, which seems to be at least something that should be in the librarian mind, which wasn't at the time, and I think still isn't really. So I saw this, like, well, there's this whole other world of people solving the same subset of problems, like how do we think about large collections of text, but they're doing tools that I've never seen and seem to be very powerful and sort of really interesting and worth pursuing more of.
So instead of classifying books, they were like classifying the entire internet at the time?
Yeah, something like that. Yeah, or any sort of text document. They were doing a lot of stuff with the Reuters corpus. I mean, it still is this sort of standard natural language processing text, and they were doing a lot of work in that. A lot of it was for government projects, so they were just building these prototypes of. It was a really interesting company because they were all research. They were trying to do business at the time. They got bought out by Raytheon shortly after I left, but they were a very research-heavy company, and it was really cool. They couldn't quite get the business working because of that, because it was like research is expensive, and they weren't really good at commodifying that. But it was an exciting place to be because they were doing tons of neat things. And my job was just to research what they were doing. So I would just read all of these, academic journals and see what people were doing. And it really gave me a huge amount of exposure to this world I never knew. And I was like, this is amazing. And this is the future of what this is going to be. So that's what, kind of at the time, I felt like there's no way I could ever do. If you told me then I would ever use a support vector machine, I would have like, no, it's not possible. It's like, I could never.
And is that when you started your computer science formal education?
Yeah, so I did. I took a class at MIT during the intersession. They have this wonderful thing called IAP, and I learned a little Python. And I built, when I graduated, that actually has a sort of interesting part of the story. So when I graduated library school and I was looking for a job, I actually built this aggregator that was a bunch of this whole collection of screen scrapers that collected, because Boston was a pretty dense library place, so there's tons of libraries, and there was no unified place to get jobs. So I wrote this tool that went out and harvested. It was like the ugliest web page in existence when I first drafted it, but it was cool. So I had this army of screen scrapers that would collect all this data, and I would build this site up, and it was, there's a lot of things that now I would automate, but at the time.
You made your own job search website?
Yeah, I did, yeah, and it was really cool. And the irony is, at the time, I remember feeling really defeated because I felt like I wasn't smart enough to automatically extract out job titles from pages. And now that I know a lot more about machine learning, I'm like, well, it's still a non-trivial problem. If you want to take raw text and just extract out job titles, that's actually not easy. And at the time, I thought, oh, that's just because I'm stupid and I can't figure this out, that I don't do this smarter solution. So it turns out that there's plenty of people still writing hand screen scrapers to collect data because it's hard to solve that problem machine learning wise. So yeah, so I did that. And so I knew a little code.
And I actually want to talk about that a little bit. So I think a lot of people have that feeling when they're first starting something new and technical. It makes you feel like totally stupid. But most of us that are at least experimenting in that area, we're smart, we're trying things. And I think by nature, what I'm hearing from you and what I know from a lot of other people in this field is that we're problem solvers. So you were trying to learn something new to solve a problem. So can you talk a little bit about how you transitioned from, not feeling like a technical person, but now you're saying it was a continuum all along. So what was that feeling like? Like what, when were there moments that you felt stupid or you felt like you were alone or you were outside of this world? And then how did you transition in?
I try to continually feel that way. I still feel that way at night. I still even doing some stuff I'm doing with neural networks, I still feel really stupid whenever I'm like pulling these things apart, and you know, even just
We
like
can all relate.
yeah. And so I think there was a point when I was becoming better, because my focus initially was just on software. I wasn't interested in I didn't think it was possible. I wasn't interested in math, and I wasn't interested in machine learning, because I thought that was just like way out of the realm of what I could do. So so yeah, I was doing software, and so I remember the point where I felt really good at software, and that was the worst point for me intellectually, because I remember I picked up a book on CoffeeScript or something, and my default assumption going in was, I know all this. This is like this. I know enough about programming languages, and this is going to be easy. And then I got no value from the book, and it wasn't the book's fault; it was my fault. And so that was a while ago. I think it's sort of like that's the defining intermediate stage. Whenever you feel the most smart, is that it's really you're the most okay. You've gotten past the beginner hurdles, but you haven't really started the journey. The long journey that never ends. And so, you know, I always think that's the hardest part of perpetual learning, is you just got to accept that you're always going to feel dumb, and you're never going to, you know, that's, if you really want to have an ego about something or feel really smart, you're going to have to block off parts of reality to let yourself believe that. And if you want to be a real explorer of ideas and thought, then you just have to accept that every night you're going to go to bed going, God, I don't really know anything.
and there's so much to learn related to data science. I think so many people feel that way. It's like almost overwhelming how many different topics there are. But I have an interest, like you had mentioned, I read in an article that you have a fascination with how we learn math and how we evolve our learning. So because, you know, this is a field where you're constantly learning, So what are some of your thoughts about that?
You know, it's really... Boy, that's a good question. You know, I have the biggest. People always ask, "How do you learn this stuff?" My answer is always read lots of books and study every night. And no one likes that answer, because they always hope I say. I remember I actually presented to a math class about data science. It wasn't a math class; it was a computer science class at the university on data science. And I said, "Well, how did you learn all this math?" I said, "Well, I read every night and I study every night. I do problems every night." And they go, "How else?"
There's no magical class that when you take the class you suddenly know everything.
Yeah, and so my big thing, actually, I still am a big believer that books are the most information dense media. And the big thing for me, whenever I learn something new, is I usually just survey all of the textbooks and find the one that matches the way I think. And that's usually the biggest thing. And it's okay, because there's plenty of great books that are hard for you personally to read, that you know, maybe famous books, because this is a wonderful textbook, this is the greatest textbook, blah, blah, blah. But if it doesn't click with you, it doesn't click with you. So I'm a big fan of finding, you know, just keep looking through famous books and until you find one that clicks with you. And then it's a blend of studying and practicing and studying and practicing. And I think, you know, one thing I've noticed that people get in the trap of on the other end is if you're grinding, you're doing it wrong. If you feel like, oh, I gotta stay up late and do all these math problems because I have to, or I'm not a good person, it's like, well, it's actually much more productive if you read a chapter on probability in a book and then tried to figure out how to solve some probability problems that you were interested in. And then when you hit that inevitable wall, you'll go back to the book and say, okay, where does this leave me? So I remember with machine learning doing Andrew Ng's course that was so famous, the one he did on Coursera. And you know, I went through half those lectures and was like, this is neat. And then went off and did a whole bunch of machine learning experiments. And then I remember 6 months later was like, crap, now I'm at a wall where I need to know more about unsupervised learning, or I need to know more about clustering. And I would go back to the class and catch up. And that's, and the same thing was, there was a wonderful probabilistic graphical models course on Coursera. Same thing, like I did most of it, and then I solved problems I wanted to solve and then went back later. So, you know, sort of follow your heart in a very literal way. Like, just really go with what, you know, if you're reading a book and you're inspired to do something cool, and then as soon as you hit that next wall, go back and keep that cycle going forever.
That is really good advice. I like your mention about finding a book that speaks to you, because there's so many out there.
Yeah.
You know, you can go to a library or bookstore and kind of preview all of them, and you don't have to buy like the one that everybody's recommending, because that might not be the one that works for you. Find one that has some project that really inspires you, or that it has enough math for you, or too little or too much math. You know, there's so many different varieties of people explaining the same thing.
Math is a really hard, learning to read math is a lot like learning to read poetry, where, you know, like poetry, you can skim poetry real quick, but you're not really reading it then. Like my favorite poem is T.S. Eliot's Four Quartets, and I've probably been reading it consistently for 10 or 12 years now. 12 years probably. I've been reading it all the time for 12 years. And, you know, I'm still seeing things I haven't seen. And math books are very similar, where it's an ultra dense. And so you pick up a 100-page math book and you go, okay. And people feel dumb because they dive in and go, I don't get it right away. And it's like, well, of course not. That's not how it works. You don't read math books that way. And so it's the same thing with technical books. And each of these are different kinds of literacy. And it wasn't actually until near the end of my master's degree in computer science that I started to actually go, oh, I can I can read any math book I want now. Like I can pick up a math book and read it. Like I know how to go through it and work through it. And that opened up a ton of learning and reading for me. That was just really exciting because it finally clicked. But it took years of practicing learning to read math books till I could get to the point where I could read a math book really, you know, sort of like fluidly, where you can pick it up and read it in the evening and get something out of it rather than just feeling stupid all the time.
Yeah, good point. Okay, so let's talk about your job. You mentioned that you worked for the government, and was that your first data job, that fellowship?
Yeah, I think it was my first real data science job. So I left libraries and I did software for a year, and I got kind of bored doing just regular software, and I wanted to do more data science-y stuff, and I was doing a lot of R for fun and a lot of statistics. I was doing a lot of Kaggle contests too, and I really wanted to do more of this. So I applied for a job with the CFPB, and they got back to me. And originally it was like a Python backend developer job. I'm like, I don't want this at all. And they said, like, you know, I noticed you do a lot of R. And I'm like, well, yeah, I mean, I would love to do R. I don't want to do Python backend work actually, but I would love to sit and hack on data. And it's like, well, we actually need that. So they called me out for that. And that job was it was beautiful. I mean, on paper, it was supposed to be this Python web developer job, but my actual day-to-day was just R. It was the weirdest thing because most people have the opposite problem. You get a research job and it ends up being dev work. And this was the rare case of getting a dev job and squeezing it into being a research job. So I spent all of my time doing all kinds of interesting machine learning stuff, a lot of visualization work, and stuff like that.
And what was the job application process with that job and your next one? You know, did you apply to tons of jobs and go on tons of interviews, or was it very focused in? You know, what was your process for finding that?
I've been really fortunate with job interviews. I haven't had a whole lot of jobs. I've had a lot of jobs and not a whole lot of job interviews. So I've had a good like hit ratio with that. I applied for a couple jobs at the time, so I was ready to move on from doing software. And this is for the government. And the government was it was like just 2 or 3. Another one didn't quite work out for reasons that, you know, totally make sense. I mean, I think most people when they're searching for jobs, especially since, you know, your target audience, people that want to be data scientists, is a lot of times if a job doesn't work out, it's good for you too. And it feels bad at the time. But almost every job I haven't gotten, I look back and I'm like, oh, I'm glad I didn't go that route because that wasn't right for me. And it wasn't right for them either. It wasn't like that they were idiots for not hiring me, and I'm glad that they were idiots at all. I said, oh, well, yeah, it was a mismatch. Those people were right not to hire me. And it's a good thing because it wasn't right for me either. The government was really, I mean, government hiring is strange because the government is a strange organization. And so, you know,
what are some specific ways that the government work is different from industry work?
Well, it's hard to say because different industry, I mean, industry work is such a huge broad category, right? I'm sure actually working in a large company and working at the federal government are very similar things. So, but the job application process, there was actually a very quick interview, a Skype interview actually. They were really excited about me, I was excited about them. And then there was a long process of paperwork to get me actually hired. That's where it was, you know, this classic government bureaucratic stuff. So it was, and so, yeah, I think, the government obviously is very much more bureaucratic than a small business, but I'm not even sure. That's one of the few places I haven't worked for is very large companies. I've worked for medium-sized private, small private, academic, government, but I haven't actually worked for very large private. So my guess is it'd probably be very similar.
And what's your favorite out of those?
I think it took me a long time actually to realize, you know, I sort of grew up with the vision that like you should get a steady salary and you should have all the health care you can get and all the benefits and perks, and your job should be well defined and it should be in an office. And I realized that that's not how I am as a person. And so when I worked for KISSmetrics, because Articulate it wasn't a startup, it was a small company. That was when I did software, and I loved them. It was a great company to work with. It just wasn't, you know, the job wasn't right for me in the long run. And then I went to KISSmetrics, had the same experience, right? I absolutely loved it. So, but yeah, there's a little bit more risk. Like when I first started KISSmetrics, they didn't have out-of-state health insurance, so I had to get independent health insurance at the time, and that seemed foreign to me. But I realized that the risks associated with working for smaller companies match my own sort of desire to take risks in product and development. So it took me a while to see that. That's the reason I wasn't happy in academia, for example, is because I'm not an academic type person, and I fit much better into a more high risk, but also higher reward, and it's more flexible culture of a small company. So it took me a while to realize that, but it's really where for me, small companies treat you like humans. So every time I've worked for a small company, I haven't felt like I felt like a friend, and people, and I've seen actual compassion on the job. I've seen people, for example, let go, but given good severance packages because people genuinely feel bad and say, well, you know, it didn't work out, but I really like this guy and don't want to see him. So that's sort of real humanity I didn't see when I worked for like large universities and stuff. So that's that's what attracts me to that.
Well, tell us about KISSmetrics. What kind of company was it, and what kind of position did you have there?
So I actually started as a growth engineer because I was just like, whatever. They had this advertisement that was like, we're looking for someone that likes learning. And so I was like, yeah, I like learning. I do whatever. So I started as a growth engineer, and the VP of product, who's an awesome guy, we talked, and he's like, we really like your data science stuff. And he's like, I don't know what to do. I don't want to steal you from the marketing team already, but let's just hire you and see where it goes. So it was a great conversation. I clicked with everyone I worked with, I interviewed with, and that went very fast. That was like a 2-week, whole process for hiring. I only applied to them during the time. I was like, oh, this looks cool, and I just loved what they had. And so I live in Reno, and it was a remote position, but they're in San Francisco, so I got to go over there quite a bit to visit the office and everything.
And for people that aren't familiar, what does KISSmetrics do?
Oh, they do website analytics. So they track all the sort of activity that's on a website, and they have all these tools to do sort of enhanced metrics, which is sort of a cool place to be doing analytics at. And so I initially was working with the marketing team to do A/B testing, and it was actually really fun because I hadn't had any experience doing A/B testing, but I knew I could figure it out. So the first week I just sat down and just figured out some sort of Bayesian models for how you'd estimate the probability of, and actually, if you want to know my thinking, there's a series of posts I did in the blog on parameter estimation and hypothesis testing that were like the end result of me just sitting down for a week saying, oh, okay, so if we have two unknowns, we can treat these as parameters we're estimating, and the probability of one being greater than the other is our probability of improvement. So we built this whole Bayesian A/B testing framework from literally nothing, and it was a lot of fun. So and there were some great people there. I really got along very well with at the time the CEO of KISSmetrics, and one of the co-founders was Heaton Shaw, who's amazing. He's huge in the content marketing space and awesome guy to work with. And so he really got me thinking about product stuff for the company. And then I transitioned very quickly into actually being working to the VP of product, who I got along so well at the interview, and also and building out more product features. So it started out as sort of regular analyst job, and then it became really quickly data science. And then not long I was the lead data scientist because we hired someone else to work under me. So it elevated very, very quickly, which is something like, speaking of small companies, especially for the sort of like how do you become a data scientist, a lot of small companies are super flexible onto what you do. So if you can get into the environment, they're really good at saying, okay, you do this well, we're going to have you do this. I don't care if we hired you to do something totally different. We need you to fill this role. So for anyone that's like looking to prove themselves and wants to figure out how they can get in, like that's usually a good way, is to go to a smaller company as whatever they're hiring for. And then once you're there, they'll say, oh, actually, you're way more valuable to us as a data scientist than you are what we hired you for. So go ahead.
It sounds like you've had that experience a couple times. So is that kind of an approach that you use again? Just get in the door in whatever job position is posted?
Yeah, I think so. I think I have sort of always sort of disregarded the rules. I don't even see it as a strategy. I just see it as the natural behavior is like, and so I just walk in and say, this is what we're going to do. And it worked out. So yeah, so then I ended up doing mostly product stuff at KISSmetrics, building out a whole bunch of things. Yeah, and they were really super supportive with, and this is something I think more small companies need to be better at, and that KISSmetrics was phenomenal with, and the current company I'm at is also phenomenal with, is supporting the idea that research is inherently valuable. And I find it kind of ironic in the startup land because a lot of small companies are deathly afraid of you doing something that doesn't provide today immediate value. But could have a huge payoff. But the thing that's funny about that is that's the whole model of a startup, right? The whole model of a startup is you don't provide value today to investors, but we're betting that if you strike gold down the road, that's great for us, which is the same proposition that research has, right? Like, yeah, today we're sitting in a lab hoping these neural networks converge, but if they do, tomorrow we might be doing something no one else in the industry knows how to do because we built this from nothing. And so, and KISSmetrics was great at sort of seeing that, and I provided different levels of value. Like I did, I built out tools we put into the product. I did analysis of internal processes. So those are sort of like, immediate return on value, return on investment. But the long run research they were very supportive of, which is great. And I think that's a huge thing that more startups need to have. And that's sort of always my pitch for why data science is so important, because you actually, even if you're a company of 10 people, if you have one person who's sitting there, doing some analysis for you, but also spending a lot of time saying, hey, we haven't tried this. Let's throw this data in a random forest and see if we can predict something we didn't know how to predict yesterday. There's a lot of value in that, because if you do get a breakthrough, then you have this edge that competitors can't catch up on nearly as fast.
Okay, so let's pause for a minute, and I want to remind everyone listening that I am Renee Teat, and from becomingadatascientist.com blog, and I'm talking to Will Kurt, and he mentioned his blog earlier, which is Count Basie, and we're going to talk about that in a minute. But Will, in the meantime, let's start talking about your tool set and some specific projects and process, specifically process. So do you have any specific workflows or advice for people that are learning in terms of a particular set of tools for, you know, setting up your data and then working with it and moving forward, or do you just kind of pick up whatever works as you go along?
It does depend on the project and how experimental, but for like for regular everyday data science stuff, the more sort of here's a problem, here's some data, start figuring something out. I love R, and I really love R Markdown. Like if you do R and you aren't using R Markdown, you're not doing it right. Like I really recommend starting that behind. I mean, for Python, it's IPython.
And tell us what that is.
So R Markdown lets you write interactive R reports. And I actually like it a little better than what it was now Jupyter and used to be IPython notebooks. So it's a Markdown format, and you can put, for me, the best thing is it supports LaTeX, so you can actually put all your math equations in there, and it will format nicely. But essentially, you have a Markdown document, and you can put live code snippets in it, and you can compile the whole thing. And the beauty of this is, and I've had this happen many times. When I first started out, I would just write R, just junk, just, you know, let's experiment with this. And you'd come back, if you've ever written R that way, you come back a month later and it really makes literally no sense. No matter how many comments
spaghetti code.
Yeah, exactly. And to be fair, I mean, it's part of, you know, exploratory data analysis should be messy because it is messy.
Yep.
But it's hard to come back and go, what was I thinking? Why am I loading this gigantic, matrix into memory? Like right now, this is it takes an hour to load. I hope I remember why I'm doing this. But R Markdown lets you take notes, and so there's Donald Knuth, the famous computer scientist, someone asked him what's his favorite method of programming. He said literate programming, which is the idea that you're writing more, and your comments are your actual code. And that's how R Markdown works. You're pretty much writing mostly, and then your R is your code. And so when you start with R Markdown, the flow for me has always been just, whatever you're thinking as far as exploratory analysis goes, just write it down. Write down your thought. You're writing an essay for yourself. Don't worry about other people. And then every time you get to a code, you go, okay, so we need to take the mean of this distribution. Like then you just write the R, and you have the R there, and you run it, and that's how you go. And the beautiful thing is, I half the time I would end up with a full-on report that I could just hand to management when I was done. So when they say, "What are you working on?" You go, "Well, here, it's a 10-page report with examples and analysis and experiments." And so that to me for ordinary stuff is really is the best way to go. I'm probably not as good with version control as I should be. I mean, I used to do software, so I know how to use version control well, but I find that it just doesn't fit with my flow as well as I would like it to. I don't think in versioning chunks of mind. So, for software, it's a lot easier to think like, okay, we're at a good stopping point. Let's commit this. But R Markdown to me solves a lot of that, just in the fact that you have this ongoing narrative on paper. And it's that was, once I started doing that, it changed my workflow. So yeah, I always recommend that. And I do like R. I mean, it's in the perpetual R and Python debate. I like R a lot for rapid iteration. If you really just want to get things and plot stuff out. I'm terrible about not using ggplot2 enough and all these nice libraries, but I like the fact that R lets me just spit stuff out really quickly. Actually, whenever I meet developers that are learning it, I always tell them that the problem they're going to have learning R is it's not. Most languages use the interpreter or the REPL as a way to help you write code, and then R inverts that. You really write R code so that you can interact with it better. The interaction is what R is about. And then, and I love Python, especially as soon as you start getting towards closer to anything you might actually want to throw at production or give to engineers. Python's usually a better way. And then it's Jupyter and IPython notebooks. So, I mean, if you're doing this work and you're not using a notebook format of some kind, you really should just take the time to learn it, because it just makes thinking so much easier, especially about these sort of weird, messy problems that we end up getting.
And since you've done a lot of work with research, but it sounds like you've been on teams with engineers that then might take that and turn it into something for production. Tell us a little bit about the type of teams you've been on and what it's like to work with different types of engineers, things like that.
Yeah, I mean, so I think the biggest value that any data scientists have, and this is thing I always look for when I've hired people in the past, is like, how can you communicate across groups? Because that's the real, especially in a small company. And I mentioned that, larger companies are hiring data scientists to do all kinds of things that are going to be, more like working in a university research lab, I think. But for the data scientists I'm interested in, sort of the, I'm a problem solver for this space, is you really want to be able to communicate with everyone well, and especially engineering. So I've met there's two types of people that want to be data scientists. People who are software people who feel like I don't know enough math to be a data scientist, so I'm learning math, and math people or or scientists that want to learn a little more code. And I really emphasize that learning to code well is a pretty important part of it, because it lets you communicate very well with the engineering team. When the engineering team believes you know what you're doing, you get a great relationship. We actually, at KISSmetrics, we had a book club, which was a lot of fun. We did we were reading.
Did you start that?
Yeah, I started. We started a math book club. So we were reading Claude Shannon's Mathematical Theory of Communication as a group, and we'd meet every other week. And all the engineers loved it. So we got the engineering department to finance a copy of the book for everyone, and we just went through it. And that's what you want. You want to have, because the thing is, your data science is most valuable when engineers trust you enough to say, hey, am I doing this right? Like, I need to implement this thing, and normally I would just assume it's an average here, but is that right? Is that okay? Or like, do you know of an algorithm that can do this better or faster? That's the ideal. And same with product and everyone else. You want people to trust you, because to me, the real value of data science is that blended thing. And so if you can help someone get a new product idea, or if you can help someone, someone from marketing come and say, I don't know, I feel weird about these results. Why are these weird? You want that. So that trust is huge. And I think trust with engineering is usually harder to get. And so that's where, having proficient engineering skills is useful, because that goes a long way into earning that trust. And also a lot of times in smaller companies, I've done a lot of low-level sort of numeric computing stuff, because we had to implement some stuff in JavaScript once, and JavaScript has no statistical primitives. So you have to know, how am I going to, if I can't get a beta distribution, how can I fake it well enough, right? And so, and not a lot of engineering teams have someone that can do that. So it sort of, I think, falls on data science. And then once again, that adds a huge value. If you can maybe you write sloppy code, that's fine. But if you can go in there and they say, okay, we need someone to implement this algorithm, I have no idea where to start. I can't, my probabilities don't work out. It really helps you able to be the one who can say, yes, let me do this for you. Here's this code. You can clean it up as you want, but that will run and solve your problem. So I think that and in general, the communication is key, and that's really the biggest thing I've seen missing when I interview data scientists, and that's because it's the biggest value add. If your whole pitch is, I have all these skills that can help your company, if you can't connect with people, then that skill set's not really worth anything.
Yeah, that's definitely important. So since you mentioned statistics, tell us about your probability blog, Count Basie. And I'm curious, did you name it because you like the musician Count Basie?
Yeah, so I'm not as super jazz buff. I really feel bad for that. It was just a really good it's related to the jazz musician, obviously, and I'm aware of Count Basie. That's what the name came from. But I've been, I'm sort of despite that I'm sort of excited in interviews, I'm a very introverted person, and I like sort of to keep to myself. So my wife was always telling me, like, you got to write a blog. You have all these ideas. You just got to occasionally I would just share these weird things I did on Facebook with my family and friends. It's like, you really got to get bigger out there and just sort of share with more people. So I was like,
I get that too. Stop talking to us about data science. There's other people that probably are more interested.
People that care about it, okay? So yeah, exactly. So I was thinking about it, like, what do I name this thing? And Count Basie just came in my head, and I was like, that is too funny of a name. It's too perfect. So I do feel bad, because I think some people assume I'm this huge jazz buff, and I'm not. I like jazz enough, but I'm not like this expert in jazz. But it was too clever of a name to give up, so I had to go with it.
So if our listeners go to your blog, what kind of posts will they find, and what do you write about?
So I write about everything probability related, and I would say more advanced stuff is actually my aim, because one thing I find is there's this huge gap between entry-level probability and sort of more advanced academic stuff. So I did this series, and they always like, write for yourself. That's not necessarily true if you actually want to write for an audience. But I did this series on the Lebesgue integrals that I personally really wanted to write, because it's all about measure-theoretic probability, which is it's usually completely off limits. Even if you've studied, there was a point where I would have said, I know all kinds of stuff about probability, and didn't know anything about measure theory. And so it's like, that's, if you get to graduate level probability, it's sort of like a foundational thing. And I just wanted to write a sort of for everyday people version of measure theory and the Lebesgue integral. So it's it's not technically masterful, but it covers the basic ideas. But I also my most famous post still is the one on I did a post on Bayes theorem with Lego, which was hilarious that it blew up, because I was like, I need to write a first post. I'm like, what am I going to write on? And I just crunched out this post in a night. It was just like in one evening. I was like, I've always. I think that's how I remember thinking about Bayes theorem when I first learned about it. I actually remember the post came out because I remember thinking about Bayes theorem that way initially, and then starting to think about it as a probabilist, and then becoming more confused about it. So I thought to myself, well, I really want to rewrite this the way I remember remembering it in a way that makes sense. So I wrote that post to sort of remind myself how I used to think about it, and I was like, oh, this is very clarifying. People really like that post. So, yeah, so I do a variety. I do some sort of wackier posts on things. Some things I try to push what I know. Like I did one that thankfully one of my readers really helped me correct and get working on void conf machines from Blade Runner and Bayes factor. So it's this really, I'm really happy with that post. It's not super popular because people don't really care about Bayes factor that much, which is like an alternative to p-values. But yeah, a whole huge range. My most recent post was on Black Friday and Monte Carlo Markov chains, and so that was also very popular, which is also funny because I just wrote that. I've been writing all week, all the time I'm actually working on another project, and so I just had some free time, so I was like, I'm just gonna write this post on Markov chains, and people liked it, which is good. So but yeah, all kinds of weird.
And what you said about remembering how you used to think about it, I've heard of a comment called the curse of knowledge, which is that once you learn something, you forget what it's like not to know it, and then you don't know how to explain it to people. So having that skill is really important in being able to communicate with people that aren't data scientists. So that's great that you're able to write that way.
The example I always have with that too is user interfaces. As soon as you learn to write code, you no longer see a web page as a metaphor it's supposed to be. Like buttons aren't buttons. Buttons, once you've done some web development, buttons are literally an event firing. Like you see that when you see a button, and it's sort of a shame because
you see the matrix, the code trickling down.
Exactly right, and it takes away from the joy, but it also limits. If you look at, like I always point to, like when you look at user interfaces written for Linux, it's always the command line arguments put into a form with like fields where they would be, because programmers don't think in interfaces anymore after a while. So the same thing with math and everything else. It's very easy to stop thinking. I love the idea. There's this idea in Zen Buddhism of the beginner's mind, which is that you're open to all things. And so I try to. I've always tried to write a post on this actually, because it's there's this hostility in tech to the idea of a noob, right? Like this idea that like a beginner is a bad place to be, and you want to get the hell out of beginner and to expert as fast as you can. And it's funny because like whenever you put stuff out there for the blog, you always get a few negative comments of like, oh, this guy is not an expert or whatever. And it's like, well, yeah, it's good. It's good not to be an expert. And it's okay to be wrong. And so, but that's the thing I think is a shame in tech, because there's this huge obsession with expertise and like proving that you know it and not showing any weakness and not going, I don't know, I'm an idiot.
That's my theory on why becoming a data scientist has really caught on, because I've been blogging. Like I originally started blogging to just capture what I was learning in a class. I took a machine learning class in grad school, and I wanted to make sure I didn't forget that stuff. So I wrote it down and wrote a post as if I was explaining it to somebody. And then I kept going with that, and through Twitter and everything, I tend to retweet articles that have to do with learning and becoming something. And when I go through an exercise, I kind of live tweet it, and I tell all the hangups and problems I'm having. And I think that's why people have kind of liked it, because they're watching me go through it instead of just seeing the end result once I know how to do it. Yeah,
and there's this huge obsession with, when I look at data science stuff, I mean, I think you've really hit a great market, because there's a huge demand for how do I get started. But, as people are getting started, especially as the target audience of this podcast, and I think that one of the biggest things is don't be in a rush to let go of that part that makes being a noob kind of suck. Like that's actually the best part, the part of the feeling of sort of wonder, and I don't know how things work, and I'm really receptive and I'm really open, and I really don't understand the world. Almost all mistakes come when you have this concrete vision of how the world works. And so, and like I said, it kind of stinks, because if you to stay there for a long time is kind of stressful, because it means you don't ever go to bed thinking you're the smartest person in the world, which is a nice feeling, even if it's a delusion. I think it's a good thing to feel that way. But if you really want to keep doing interesting things, you just have to accept that you're going to never be confident that you can't let that cripple you either. That's the other thing. That's the flip side, is you can be way too hard on yourself with, I'm just a beginner, I don't really know anything. So the balance is finding a place where you can be content with that, and sort of, I always say, like, be really hard on yourself when you're working in your lab, in your own little science space. And then if the rest of the world wants to say you're brilliant, let them say it. Don't correct them. If people want to say that the blog is great. I'm not going to stop anyone from saying that. But when it's me and a book at night, then that's when I'm the hardest on myself. And that's when it's you don't know anything, and you have to be open. So, but the thing is, if people learn more, there's a real rush to prove yourself, to go to meetups and be like, well, I did well in a Kaggle contest, or I did this. Which is good, because you want some feedback, but it's also a trap, because as you go deeper than that, and you reach a wall and you stop growing. So you always be a beginning data scientist, right?
Well, I think that's a great point to wrap up. So thank you so much for being on our Becoming a Data Scientist podcast. You are the first episode, and so I welcome all the listeners, and I welcome you, and thank you for being a part of this.
Well, thank you so much for having me, Renee. It's been great.
All right, thanks. Bye.
Bye.